Hi folks, my name is Andrew, on a crypto YouTube channel. I have already mentioned proof of work and proof of stake algorithms several times, but did not say anything about them. But today I decided to share this information with you. It's just important and useful for understanding which cryptocurrencies is more suitable for you, and of course for understanding how it all works. Let's start. The basis of all modern cryptocurrencies is the principle of peer-to-peer networks, in which every node is an independent unit and can participate in transaction confirmation and formation of a blockchain network. In order for the network to function normally and to exclude as much as possible attacks on the network, all nodes of the network must mutually confirm and approve each other's actions to reach a consensus on the information of each transaction and the creation of a new block. The right to generate a new block is precisely determined by the consensus model, or, as it's often called, the consensus algorithm. In fact, the consensus algorithm is a set of definite mathematical rules and laws that regulate the work of the blockchain. For example, it manages the frequency of generating new blocks. This helps to eliminate situations where each node generates its own block and writes it to the block system. In the Bitcoin blockchain, a block is generated every 10 minutes, totaling 6 blocks per hour. Sometimes there are situations where several nodes are generated almost simultaneously, with a difference of several fractions of a second. Then a conflict arises that is resolved in favor of the node that created the block first, and the one that was a later one is written down after that. Another function is checking the correctness of the data in the block. All nodes must confirm the correctness of the data of the block that was generated by a specific node. The transaction hashes of the previous and the generated block are checked. Avoid respending. Example: in the blockchain of Bitcoin, where the transactions to the block is requested, all funds from the wallet are sent at the same time, after which the specified amount leaves to the recipient, and the balance is returned back to the sender's account. Currently, the most used algorithms are proof of work and proof of stake, but there are also others, but they are used in much smaller number of coins. This is due to their relatively recent appearance and the insufficiently developed technology. Examples include proof of importance. It's less popular, but it's interesting in its essence and is expected to grow in popularity in the coming years. Let's first consider proof of work. The algorithm was designed long before the first cryptocurrency in 1993. This algorithm is slightly older than me. Officially, the term proof of work was proposed by Marcus Jacobsen and Ari Jewels in 1999. In 2008, all these developments were combined in Satoshi Nakamoto's project, which we know as Bitcoin. Sometimes proof of work in relation to Bitcoin is called the Nakamoto consensus. It provides the operation of the network of block computers and is used to generate a new block and ensure the safety of the entire network. The blockchain network, working according to the principle of the proof of work, functions as follows. The nodes of the network perform mathematical calculations, using to find an unknown number in a random way. This operation is simple, but it requires large computing power. When one of the nodes finds this unknown number, other checks the correctness of the results by simply substituting the found number in the formula. After confirming the correctness of data, the block is generated, and the compensation is paid to the node that found the correct solution. In the proof of work model, two parameters play the main role: computational power, hash rate, and the probability of finding a random number of nodes. However, these two parameters are interrelated. More hash rate, more chances of generating the block. In the view of the huge growth of the Bitcoin network, very large capacities are required to generate the blocks. So now Bitcoin is mainly concerned with pooling. By 2012, the total hash of Bitcoin network exceeded the computed power of the most powerful supercomputer in the world. The advantages of the proof of work algorithm can be attributed to the impossibility of forgery, because the results are checked by all nodes of the network before being written. The impossibility of preparing the result, since the work on finding the next unknown number begins only after the previous one is written. Honest earnings. The amount of potential remuneration directly depends on the hash that the node has. However, today this advantage is rather controversial, since almost 70% of the total hash is concentrated in one country, in China. Algorithm proof of work is used in many popular cryptocurrencies: Bitcoin, Ethereum, Litecoin, Dogecoin, Zcash, Monero. But how does proof of stake work in comparison? This algorithm was first proposed by the user at Bitcoin.org in 2011 as an alternative to the proof-of-work Bitcoin. Proof-of-stake is also called forging. The first coin, which was specially realized on the algorithm of proving the share of ownership, Peercoin. And to be more precise, the hybrid version was used in Peercoin. The principle of mining using the proof-of-work algorithm was initially used, and after all the coins were extracted, the transition to the proof-of-stake was introduced. Some coins in accounts that participate in forging are frozen, as some kind of guarantee of the integrity of the site. Coins are in frozen state until one block is generated by one node, and the other participants do not confirm the correctness of the master's action. Such a freeze is also a precautionary measure that helps prevent network attacks, avoid double spending of coins, and exclude the possibility of validating counterfeit transactions by nodes. Unlike proof-of-work, in proof-of-stake the determining factor is the number of coins in the node account. The more coins are stored in one wallet, the more chances to generate a block and get a batch of new coins. The participant that wins in a fight is called a mastercraft. The principle of proof-of-stake is in some ways similar to playing roulette. The more bets you make, in our case we mean coins, the higher the chances of winning, getting a reward in the form of cryptocurrency. The advantages of proof-of-stake over proof-of-work include energy efficiency. Unlike the traditional proof-of-work, the proof-of-stake algorithm doesn't require staggering energy consumption. The energy is spent only on the confirmation of the transactions themselves. Low resource requirements for equipment. Everything you need to participate in forging – a computer, a regular PC or a laptop, a stable internet and an installed client program. A low commission. Unlike Bitcoin and other coins that work on proof-of-work, and whose commission is pawned apart from processing by transactions, miners also paying bills for electricity. Transaction of coins for proof-of-stake are cheaper in view of the lack consumption of energy resources. Greater decentralization. In order to create a stable masterwork and in fact have full power over the process of confirming transactions, you will need to have just a huge amount of coins. However, there is also an opposite negative side. Theoretically, it's possible to redeem most of the coins, consolidate and seize power over the forging of a certain coin. But the probability of this is very low, because it's meaningless. The low probability of an attack of 51% is complicated by the fact that the forger must have more than half of all coins. First, it's very expensive, and secondly, the attacker will suffer from the attack the most, since the cost of these coins will drop after the attack. Another disadvantage is the high threshold of the entrance to participate in forging. The node must have a certain number of coins. For example, for Dash you need to have a minimum of 1000 Dash, and now it costs about 150 bucks. A small profit. In this case, low commissions become not a virtue, but a disadvantage, because when forging it will be possible to earn as much as on mining. And the impossibility of turnover of coins. To participate in forging, you need to have a certain number of coins on your account, and not to remove them. You will not be able to make purchases, exchange coins on the exchange, or conduct any other operations. And now, let's talk about proof of importance. This method of protection is designed to distribute profit evenly among the nodes that are actively involved in the process, as well as bringing maximum benefit to the network. At the same time, the principle of determining the leading nodes by the number of coins is ignored. This is the main difference between proof of importance and proof of stake. Nodes of the highest importance receive the highest chances of creating subsequent blocks. This principle of work encourages frequent use of electronic currency as an instrument in trade and is an obstacle to accumulation. With the help of proof of importance, serious drawbacks related to proof-of-work algorithm are also overcome: energy cost, centralization, and so on. And there are a lot of them, but most of them are combinations and derivatives of these three. I hope that this video helped you understand this rather complex topic. If you want me to briefly talk about the other algorithms, tell me in the comments and I'll gladly do it. For today, that's all. Don't forget to give me thumbs up, I really appreciate this. See you next time. Bye!